Even in modern automatic packaging machines, blank feeding is a repetitive task currently carried out by humans, making it quite inefficient and prone to error. The palletization is done by a robot in a cage in a very controlled and structured environment that is unsafe for humans. TIMAIRIS Showcase round was composed by a simplified version of the complete blank feeding problem that included a prototype of a blank magazine, the mechanism that feeds the blanks into the packaging machine, and 2 pallets filled with actual blank piles used in production. The workspace is assumed to be shared by a human and a robot. The task consisted in recognizing the blank piles on 2 different pallets, devise a plan for picking them, and transport and place them in the blank magazine in a smooth way. A fusion of RGB and depth information was used to detect the pose of the pallets and the blank piles. The dispositions of the blank piles in the pallets required a plan for picking order. There are piles that need to be picked up first, otherwise manipulation was not possible. Blanks are provided in piles, piled up on pallets close to each other, which can cause erroneous detections. Depending on requirements, blanks can have different printed patterns for the same blank shape. Therefore, detection cannot rely on approaches such as color segmentation or features matching. Using a single arm, the robot had to pick blank piles from 2 pallets that required navigation planning and arm motion planning. The blank pile is not a unique, rigid and solid object. Not only it bends, but is also the result of the stacking of a considerable amount of blanks that can easily break free from the pile due to low friction between them. To prevent the breakdown of a pile, any manipulation has to be aware of this fact. The pile is picked with the stamped side facing up, but must be placed with the stamped side facing down. This entails a complex constrained motion plan that keeps the vertical orientation of the pile. This requires arm motion planning with proper inverse kinematics constraints and the use of compliant modes. The detection of the blank magazine also uses a mixture of RGB and depth information. The feeding of a blank magazine is a manipulation action that requires a high level of precision for a proper feeding and to prevent collisions between the blank magazine and the manipulator. After feeding the magazine with the first pile, the robot will now continue for the next pile on its plan and repeat the process. The manipulation of a blank pile is performed using a single arm with a gripper. Because of how blank piles are arranged in the pallets, they must be dragged to the edge of the pallet and then grasped. Such manipulation had to be done using a single gripper that had to be designed and manufactured by TIMAIRIS for the blank feeding task. In this situation, the robot is waiting for the feeder to report that it needs more blanks. This can also be visually confirmed. In this example, the robot has to reach for a pile that is on the opposite side of the pallet. In the following demonstration, the robot is given a different set of blank piles and the host member is invited to slightly move both pallets on purpose to show the resilience of the perception system to unexpected changes in the environment. The robot gives preference to the pallet with the lower number of piles. The robot has to be able to navigate in an environment that is shared with humans. This introduces a safety concern, but at the same time, it gives the opportunity to take advantage of the human-robot proximity to explore human-robot interactions. In this example, the robot is waiting for the start command that is given by gestures. For safety concern, the presence of a human in the vicinities of the robot triggers a generalized motion stall. Humans near the robot are tracked using laser scanners, and when within the interaction distance, the pan and tilt camera keeps its attention on the closest human to recognize possible gesture commands. The robot is also aware of the presence of a human while manipulating the pile. Whenever a human approaches the robot, any arm motion is stopped for safety reasons. To conclude, a time-lapse of the extra demo is presented. Also to be noted, the fact that the showcase solution, although not focused on time efficiency, is already fast enough to fit simultaneously two packing machines.